Hello all and welcome to this tutorial. In our tutorial today, in very simple words, we will discuss what is a DDoS attack and what are the various types of DDoS attacks. Let us begin this discussion with what is a DDoS attack. DDoS stands for Distributed Denial of Service. Now there are a couple of keywords over here, and the first keyword is distributed. That essentially tells you that this attack is not a central attack, it's not from a single location, but it is distributed across different sources or across different, in this case, computers or hosts that attack a specific system. Okay, so it's distributed in nature, so it's not coming from a single location. Denial of service, that means the service is not going to be available because you have been attacked. So that's what DDoS stands for. It's a distributed denial of service attack. That means you have been attacked by multiple requests or multiple packets or multiple servers, multiple bots, whatever the case may be. It's a distributed attack that has caused your service or your application to not be available to its legitimate users. Okay? So if one has to describe what is a DDoS attack, it is actually a malicious attempt to affect the availability of a specific target system, such as a website or an application, for its legitimate users. And how does this attack happen? Attackers generate large volumes of packets, requests, by leveraging or using several compromised or controlled sources to generate the attack. Remember, it is distributed in nature, right? So you will have to use several different sources or several systems or several bots or some kind of a software or multiple servers, right, to generate this kind of an attack. Now, as a result, what happens is when such large volumes of packets or requests are generated, it actually overwhelms the target system. The system that is under attack is the target system, due to which it starts performing poorly and becomes unavailable to its legitimate users. Legitimate users are users who genuinely are trying to connect to this particular system, but they are being denied of that service because there are a lot of fake requests or a lot of other servers, right, that are attacking this particular system and making it unavailable to its real legitimate users. And we will see how this happens. DDoS attacks can be segregated by the layer of OSI model that the attack happens on. Now, the common layers where this attack happens on is on layer 3, which is the network layer, the transport layer, the layer 4, presentation layer, the layer 6, and layer 7, which is the application layer. Okay, so I hope that by now you have understood that this is an attack which is carried out by multiple systems or multiple servers or multiple bots, right? And the intention behind is to bring the target system down by either congesting its network or by depleting its resources. How do you deplete servers' resources? You deplete servers' resources by making it super busy, by sending it fake requests, by sending it fake data packets, okay? So it just keeps on processing and it depletes all its resources, or by opening up fake connections or opening up connections and not closing them, right? So in short, what is going to happen is that target system resources are going to be depleted. It is not going to be available. It's going to be super busy. And the legitimate users or the real users who are trying to connect will not be able to connect. Okay, so this is the simplest way that you can understand what is a DDoS attack. Okay, so now let us look at what are the different types of DDoS attacks, right? Now this is the OSI model 127 right here. right? And for each layer, there's a different type of attack. So if you start from layer 7, which is the application layer, you have HTTP floods and DNS query floods. 6, you have SSL abuse. 4, you have SYN floods. And for layer 3, you have UDP reflection attacks. Okay, so let us start with this one, HTTP floods that happen at layer 7. Okay, so now let us assume that we have this web server over here, right? This is our HTTP web server, right? And we have a bunch of legitimate users, and they are basically accessing our system. Okay, everything is going great. They're able to connect to our servers. Everything is awesome. But then, guess what? Our server got hit by a DDoS attack. That is because this particular hacker who was over here said, hell, no more. No more of this great service going on. I'm going to get the server down, right? So what our attacker does or a hacker does over here is that he basically sets up multiple bots, okay, or multiple servers. Generally, it's bots these days, right? So you have multiple bots, and these are in millions, right? So you could have these in like hundreds and thousands and millions, actually. And all of these bots will actually generate an HTTP request. Now, this could be a GET request, it could be a POST request that will go to our web server in a simultaneous manner at the same time, right? So all of these requests are being generated and they are hitting the server at the very same time. So suddenly our web server will receive like 10 million requests, and it's going to be overwhelmed. It is going to think like, oh, I don't know what's happening. How am I supposed to generate and responses for all these different requests? How am I supposed to handle and manage all of these requests? I really don't know what's happening, right? But the only thing is that all of these requests are fake requests, okay? Because this attacker is generating and constantly bombarding us web server with these fake requests. So as a result, what is happening is a server is busy, okay? It does not have resources. It is overwhelmed. It is responding back to these fake requests, which is not necessary, and it's just continuously being hit. As a result of that, our legitimate users who are over here, these are our legitimate users, right? Our legitimate users will not be able to reach to our web server anymore. They will actually get web servers busy. Okay, so they are denied of this service. Why? Because there is this distributed attack that has happened. And this is actually an HTTP flood attack that is happening, that is, causing the server to be overwhelmed and getting this very service down. So this is a typical HTTP flood attack, right? Now the DNS query flood attack, which is another one at this particular level, this one, works in a very similar manner. The only difference is that instead of the HTTP server, let's say this is your DNS server over here, right? So our user is trying to go to abc.com. So it sends this request. This will typically send back like, okay, 172.19.2.28. I'm just cooking up some IP address, right? Okay, this is the IP address, go there. This is what happens generally. But now, if it is under attack, then again, there will be, remember, it's a distributed attack. So multiple servers, multiple requests, bombarding your DNS server, right? With fake requests for abc.com or whatever it may be, right? So your DNS server is now responding back to all of these fake requests. And our little user over here, right? This little guy, if he sends his request, he will basically get server is busy or, site not found or something, some form of message or some error, or he's just continuously going to sit over there and wait. Why? Because our DNS server is currently being bombarded by DNS query requests, okay? And all of these requests are fake in nature. So I hope that this was clear. Okay, now the next one that we have is an SSL abuse request. And it's kind of in a similar manner, right? So again, let's say you have your HTTPS server, right? And this has your SSL port. Again, it's your web server, right? And you have your standard users who are trying to connect, right, to its SSL port. They're trying to establish an SSL connection, trying to perform an SSL handshake, right? But what happens is that you have a hacker over here, and his intention is to bring this server down. So again, you will have multiple bots or multiple servers attacking this particular server. Now, in case of SSL abuse, there are multiple things that could happen, and it could be one or more of these, or you could, have quite sophisticated attacks as well. I'm going to stick to some of the most simplest forms, but the easiest way to get the server down is to connect to this particular SSL port, right? Let's say it's on 443, open connections, okay, and not close them. So it will just bombard it with requests, open a whole lot of connections and not close any connections, okay, or open them and close them after a while. So that's one. The second thing, it could be that hey, it's trying to connect to this SSL port over here on your server, okay, and it's trying to negotiate the SSL handshake, and it's trying to figure out, hey, what are the various ways can I negotiate? It's just trying to keep that port busy. Okay, sometimes it will try to negotiate even the SSL encryption type. And the third thing that it could potentially do is send a lot of garbage data, right? So it's going to send a lot of data packets to this particular port and just keep on flooding it with a lot of data packets, right? So you can send a lot of DP's data packets to this particular port and just keep on bombarding it. The port is going to listen, it's going to accept those packets. It's designed for that, right? And it's going to open up those packets, look at the packets, and then it's going to be confused. Either it's going to discard the packet, or it might go and look for something if it's mentioned in that packet, depending upon what it is. But the intention is to keep that port busy. So as a result, what is going to happen is that if the port is bombarded with all of these packets, and it's going to be busy, its resources are going to go down, right? And this particular connection from our legitimate user will not happen. Correct? Now, on the other hand, let's say if the hacker was trying to open a whole lot of connections and not closing them, then it will have too many connections that are open. Okay, or if it's just bombarding it with SSL requests and keep on hitting it, just like how we had HTTP requests, you could have multiple HTTPS requests coming in. It's just being bombarded. Then in that case, it will have too many connections, a lot of connections open, its resources will be depleted, and your legitimate users, or the real users, will not be able to connect. Right? So this is in general what typically happens in an SSL abuse. Okay, so now let's move on to the third one. The third one is what? The SYN floods. Okay, so let's say that you were over here, this is you, right? And you had your little computer, and this is your server, right? And this is you, your laptop or whatever. So typically what happens is that you send a request, right? Or SYN request to your server. Your server is going to receive that request, and the server is going to return back an acknowledgement or a response. This is the server's response coming back. It's also called as SYN response or acknowledgement. Okay. And your laptop or your machine or your server, whatever the case may be, receives that. And then again, it is going to respond back to your server saying that, okay, I got the acknowledgement. Thank you. So it's going to return back to a response back to your server with another acknowledgement. So if you see over here, this is a 3-step. This is step 1 when you're sending the request. This is step 2, when you actually receive a response for your request, like an acknowledgement from the server. And step 3, you are basically acknowledging that you've received acknowledgement from the server and telling the server, okay, thank you, I got it, it's great. And the server is going to close the connection. So you see the 3-step process. There's a 3-step handshake over here. Now, this isn't how it works normally. If you are under an SYN flood attack, what is going to happen is you will have a whole lot of these, bots or servers or machines or whatever you want to say, right? Who will complete the first 2 steps, that is this step and this step. They will send a request. Of course, the server is going to receive the request and it is going to send back an acknowledgement. But they will not complete this entire communication, right, of sending the acknowledgement back. So as a result, what is going to happen is server is going to send a response to the request, and it is going to wait for this particular server or that particular host from which it received the request to send an acknowledgement that, okay, my acknowledgement that I had sent has been received by my host. So this particular step will not happen. As a result, your server is going to have a lot of open connections. There's going to be too many open connections. Okay? And because of that, it is going to deplete in its resources. Why? Because it's constantly being bombarded by multiple requests. It is responding to that request by sending an acknowledgement, but it is still waiting for that host to send back an acknowledgement to itself, right? So this particular step 3, is not happening. So the server is waiting and is waiting and is waiting to get an acknowledgement back from the host or the source that it came from, but that acknowledgement is not coming. And as a result, it has too many open connections, it is depleted in resources, and the server is performing very poorly. So then if a genuine request comes in, right, a real request comes in, it is not going to be able to cater to that request. Why? Because it is busy responding to all these fake requests, and it is still waiting to hear back from those initial requests that came from those initial fake sources that these requests came from. So this is typically an SYN flood attack, and this is very common. It happens all the time. Now let us go to this one. This is the UDP reflection attack, and this one could become a little complicated. Now, for those who do not know, UDP is another protocol. Okay, just like you have TCP is a transport protocol, there's another protocol called as UDP. The difference between TCP and UDP is that TCP is a connection-based protocol. That means it establishes a connection first, okay, and then sends the data. UDP, on the other hand, is a connectionless, stateless protocol. That means it does not establish a connection, but it will simply send the data, okay, without establishing a connection. Okay, so let us see what happens in this case. Okay, so you have your server or your source that is under attack, your target system over here. This is your source or your target system. Okay, this is a system that is under attack. And this system's IP is, let's say, 192.10.2.1, okay, some IP. Now, whoever has decided to attack this particular system, let's say this is our hacker. He has decided to attack this particular system. So what this person needs, the first thing that this person needs is a system or a machine that is on UDP or UDP compatible. Okay, and he or she is going to generate one or more requests. So let's say this person generates a request. Now, when this request is going to be generated, right, this request will potentially be sent to a set of UDP servers in between. So there are a set of UDP servers, and there could be a set of UDP servers. Again, there could be another set of UDP servers to amplify the effect. Okay, it could get complicated, but let's just make it very simple right now. So let's say that this person creates this particular request. So this person sends a request, and as part of this request that it is going to send to these are UDP servers, right? So this request is going to have your target as these UDP servers IP address. And the source is going to be this. That means what this person is doing, what the hacker is doing is he's manipulating the source. So this particular server from where he is generating these requests, this server is capable of manipulating the source IP. So let's say the source IP is going to be this 192.10.2.1. Now these requests are going to go to this server right here. And these servers are going to get these requests. These are UDP servers, so they're going to accept that request. And they are going to look at that request and then say, oh, this request has come, but this request has come from 192.10.2.1. I should respond back. Okay, and now these servers are going to generate another set of requests and basically bombard this server. And this target server is going to suddenly get a whole bunch of requests that it never ever first generated in the first place, right? But it has just been hit by too many requests. So these could be requests. These could be just data packets that you are sending with the source IP address as the target's IP address. Okay, it is possible. Now, if you want to amplify the effect even more, right? You could have these as bots, okay? And then have actually, let's say, another layer of UDP servers, okay, that are generating these requests or basically forwarding these requests to the target or source. You can say they are basically responding back, right? And these bots, what they are doing is they are constantly creating these requests, sending to these UDP servers. These UDP servers are opening up those packets or opening up those requests, seeing that this is coming from this particular source, and then sending it to this source. So you can imagine that this target system is going to be under a lot of stress suddenly because it's receiving this continuous flow of data packets or continuous flow of requests just coming in, and it is wondering where all of this is coming from. And its network is first and foremost going to be congested because it's too many requests, too many data packets coming in, right? And the server is going to be super busy. As a result, it will eventually start performing poorly, and it is not going to be able to cater to its real or legitimate users. Now, these UDP reflection attacks can get really complicated, but this is some of the simplest forms that you can have. You can have super amplification, right? When I say super amplification, by that I mean, for example, you have your hacker over here who's generating maybe one single request. You could have your bots over here, right? And these bots are going to, your UDP, let's say your UDP servers over here, right? Or they could further go to another set of bots, right? Which are further amplifying that, okay, this bot actually basically, let's say, sends 100 requests to different other bots, and that bot again generates another 100 requests, and then you can have another bot that is generating another 100. So it's amplifying, so it's multiplying, right? So it's just continuously targeting. At the end, you might typically have, let's say, 100 million requests that are targeting one specific server or system over here. And imagine that this continuously happens. It's just they are just hitting this one particular server. The intention is to bring the server down, or basically just deplete it of its resources. Or eventually the server is just going to give up, right? So yeah, I mean, you could complicate this as much as you would like to. And some of the sophisticated attacks typically go, around the globe, or they leverage servers from different parts of the world as well. I mean, you could complicate this as much as you would like to. Okay, guys, so I hope that this particular tutorial was helpful. I've tried to simplify DDoS as much as possible. Okay, and do post your feedback, and I will see you in some other video. Till then, take care. Bye-bye.